Hello and welcome to Eddie's Beat Shack. And today what we're doing is we're looking at decision theory. And this is the first part in a series of little episodes which will give you an understanding of certain key aspects with regard to decision theory. Now what we're looking at here is the risk and uncertainty surrounding different types of decisions. And before we can get into a detailed analysis of how to utilize some of these different ways of dealing with risk and uncertainty, we need to understand what they actually are. Now, from a risk perspective, risk is assessed. We know exactly what's going to happen. We know all of the potential outcomes. We know all of the outcomes with an element of certainty. We can give them percentage chances. You can use an example such as a roulette wheel to say it's going to come in at a certain number. Therefore, there are certain amounts of odds that a number will come in. Hence, you get a return if you were to gamble in that type of environment. With regard to uncertainty, this is where you can't see exactly what's going to happen. So as a for instance, it's supposed to be summer. Is it going to rain this summer? Well, of course it is. How much rain are we going to get? We're not sure. There's the uncertainty. So risk can be assessed with an element of certainty so we know exactly what's going on. Uncertainty, we're not quite sure what the situation is. Now, when I'm dealing with uncertainty, what I need to do is perform sensitivity analysis. So when I'm looking at uncertainty, we need to look at sensitivity analysis. And I would recommend you go and have a look at the extra little Beat Shack session with regard to sensitivity analysis, just to make sure you've got a complete understanding of everything which is going on here. Because what we're now looking at within this session is decision making with regard to risk. Now, there are different ways that we can take risk on board. And one of the ways that we can do this is because we know all of the outcomes and we know the percentage chances of all of those different outcomes, what we can do is we can multiply the percentage chance of that outcome, which is the probability, multiply that by the expected outcome, and then work out what we think we have as an expected value. This now gives me an overall average value if we had the potential to do this type of investment or make this decision potentially 100 or maybe a couple of hundred times. So expected values come up with an absolute figure. And if you are taking some sort of exam in this, then yes, you may have to understand how to calculate an expected value. You know what? I'm not going to give you many marks for this, maybe just 1 or 2 if you're lucky. From an expected values perspective, these things are really good because they're very easy to understand. I can see exactly what's going to go on. I can include multiple outcomes, which is superb. Calculations are amazingly simple to work out. I can just do this on a line-by-line basis and then add them all up together, which is brilliant. The downsides to using this type of expected value calculations, and there are significant limitations here. First and foremost, probabilities are going to be estimates of what's going to happen, therefore they may not be absolutely accurate. So you may find that there's an element of uncertainty surrounding the probability. Wow, this is getting complicated very quickly. Let's stick with the risk side of things. So probabilities may not be absolutely spot on. There may be a best guess, which means there may be a lack of accuracy in there. You may also find that with this type of expected value, we are doing this expected value calculation based on the possibility that we can make this type of decision 100 or maybe a couple of hundred times. In reality, you may be only able to make this decision once. And what now happens is the expected value gives you a long-term average, which you will never, ever, ever get. So it gives you an expected value, which is a long-term average that you will never, ever, ever, ever get. And you may now find that, you know what, maybe I don't want to do this because maybe the expected value is too low and maybe the percentage chance of me making a loss is now too high. And we'll have an extra example of that, an illustration of that when we get into part 2 of these decision makings, looking at expected value calculations in a bit more detail. Also, it completely ignores my attitude to risk. This is really important. And when you're thinking about directors making decisions within a company, the directors need to take into account the risk appetite of the key stakeholder groups. In this instance, we could be thinking about shareholders. That could be the really important aspect to me. These expected value completely ignores everybody's attitude to risk, and it completely ignores the time value of money. But you've got NPV calculations, which will allow you to work out the time value of money aspect. So there are ways around that. Other ways around that is to use these different models. So instead of just using expected value, so expected value would normally be the beginning of my analysis. Now what we do is we use an additional set of models which allow me to take into account the risk appetite of the potential decision maker or the stakeholder group I'm making the decision on behalf of. And the first one I'm looking at is maxi-min. And what we're going to do here is we're going to maximize the minimum possible return. So we've got maxi-min, which is maximizing the minimum possible return. And what this does is it looks at the worst possible outcomes and then chooses the decision which generates the best return for the worst potential outcome. And the way to think about this is the outcomes will be decided by external factors, and you now make a decision as to which one you want to go for. So you now say that I could potentially produce 100 or 200 or 300 units. In the worst case scenario, I'm not going to sell many units, so maybe I should just be producing 100 units to minimize any type of loss. So maxi-min is effectively the pessimist's view. So maxi-min is the pessimist's view. The other side of this is maxi-max. And with maxi-max, what we do is we maximize the maximum return. So we pick the option which gives me the best possible return. So I maximize my maximum return. And with maxi-max, this is very much the optimist's view. So maxi-max thinks that the external factors are going to be fantastic. Yeah, let's go and have a go at the most bestest thing we possibly can and maximize my overall profits. So maxi-min is the pessimist, maxi-max is the optimist. Then we have the in-betweenie, which is my mini-max. And what the mini-max does is it tries to minimize the maximum regret. So mini-max tries to minimize maximum regret. And it minimizes maximum regret by looking at a payoff table. And then from that payoff table, we will derive a regret table. So we start with a payoff table, and then we go to a regret table. And then we will pick the option that will give me the least amount of regret. So we'll pick the option which gives me the least amount of regret. Now, if you carry on listening to these little podcasts, number 3 actually has an example of this. So Decision Theory Part 3 will have an example of this. Decision Theory Part 2 is all about expected values. That brings us up to the end of our short little brief session here, guys. I hope you found it interesting and useful. Thank you very much for your time and attention. I'll see you all bright-eyed and bushy-tailed on Part 2